I turned the recorder on. So let's click over here on questions real quick before you see. Everybody did. Okay. I think these middle ones here are what we're going to see with sigmas. Okay. So I'm going to at least show you how to narrow this one down. So if you guys will watch. Okay. What is the length of our interval here? Let me zoom in a little bit. Our length of our interval here is 5 because we're going from 3 to 8, so it'll be 5. So we just subtract those. That gives us our length of our interval that we're looking at. So that means that our delta x, or the width of each rectangle, should be 5 over n. So you can see on your answer choices that this one has 1 over n, this one has 1 over n, this one has 5 over n, and then the answer down here at the bottom has 5 over n. So you could eliminate A and B based on that. So that, yes. I can't remember. I'm feeling like it might have been on the free response. Yeah. It's one question.
It would only be like part D.
I'm just trying to go over this quick. Yeah, it would not be a huge part. It would not be the whole question, for sure. Yes. It's a shame, isn't it? Crying shame. All right. So, yes. So, the length, remember for these that n is number of rectangles. So, if we have a length of 5 and we're splitting it into n rectangles, we would just do 5 divided by n. So, so it's not going to be A or B because they would only have a width of 1 there. And yeah. Yes. Yes. And so here, I don't like this problem. It's difficult because the other sort of trick I told you was you could plug in that n, but if you do that here, it's 1 plus 5n over n. N's cancel. You get like a square root of 6 here. Whereas down here, you would do 4 plus 5n over n. Those cancel. You get square root of 9. We really want one of them to be 8. And neither one of them are 8. But it's because your equation is 1 plus x. So you really want, if you plugged in that 8 right there, you get 1 plus 8, which is 9. So D is the best answer. I'm not going to elaborate further. This will help you see your limits.
Right. Why did you get it right, Jack?
So, if you plug in n is the final number you will be plugging in that summation. So
whoever got it right is cheating. Check. Who was it? I was on the top.
Oh, I gotta click here first. These were the 3 highest grades that we had. Yes. All right. All right. Okay.
So why do we plug the 8 into the x rather than the 3?
I'm plugging the n in right here.
Oh, I meant like to get the 9 and the 6.
So I just plugged in n into what was underneath the square root. So like right here for the n, which is, I plugged that in for the k.
Yeah, you got it. Why do you want it to be 8? Why is 4 equal the square root of 9? That makes sense, but I don't.
Because ends would cancel right there. I wasn't writing.
4 plus 5. Holy crap, I'm an idiot.
Yeah.
I got you. So that's just simple addition.
Yeah.
Wow.
Yes.
1 plus 5 and
So this could be broken down, and I don't want to spend much more time on this than this. This could be written like this: 1 plus 3 plus 5k over n. So if we think about plugging in here, I'd have 1 plus 3 plus 5n over n. The n's would cancel. And so that would be 1 plus, I'm going to put that 3 and 5 together to get 8. There's the 8, that's the upper limit. This 3 right here is that lower limit. We really didn't do enough of this for you to do that very well, but hopefully we won't see one like this on the exam. You won't see one quite this difficult tomorrow. That's the upper limit. We want it to be 8. Sometimes it turns out to be 8, but because you had that 1 there, it didn't. But okay, let's look at what else we didn't do so well on. We're actually doing pretty good on the ones here at the end.
Everything past like 11. Alright, who got this one?
Oh, so we already did that one.
I wonder what 3.
Alright, here's another one. What you're more likely to see on the test is to go from this to the integral expression. So what you're looking for whenever you see this is this, this 3 over n right here. That tells you your delta x, which tells us that the length of the integral is 3. So that narrows it down to a or b. And then, if we think about, notice both of these are just 4th roots. So if we think about plugging in n, 2 plus 3n over n, the n's cancel. That would give you the 4th root of 2 plus 3, which is the 4th root of 5. That is the one you want to end at, so that gives you b. So, 5, yeah. And then since you know your length of the interval is 3, it would have to start at 2 in order for that to happen, which is where this number right here comes from. Change it to fractional exponents, yes.
So that means the length is 3. That means that on the interval like a and b, the difference between 5 and 2 is 3. The difference between 3
I'm ready to have a question.
the length of the interval itself.
Yes.
So basically, when you plug on your n, that's just saying after it finally reaches the infinite amount of
what do you end up at? Yes. It's not so bad if you have a very simple equation like a 4th root, or if it's like on the other problem, like it's r of x. If it's like that last problem we looked at where it's got that 1 in there, it kind of throws it off and makes it harder. But this is 6.
We got 50% on this one.
Okay, Eli, yes.
Is it coincidence, or is the number, like the 2 plus the 3 over n, is that number always the bottom of the interval?
It's usually the bottom. If there's a weird, so like on 7 it wasn't, because on 7 our bottom number was a 3, but we had a 4 right here. The reason is because our equation was 1 plus x instead of just the square root of x. So that's the reason it didn't match. Usually they give you something pretty simple. So it is common for that number to be your lower limit.
So if in the answer there is, say, just the x, like a and b is just the x, then it would probably be 3. I mean 2.
Yeah, probably be 2, yes.
And if it was C or D, it would probably be 4.
Yes.
Who got that one right?
Let's see. Who got this one? Jack, Alfredo, Logan, Emerson, and Eli.
Jack, that's really sus. That's very sus.
I was already suspicious of Jack. Whenever he got a perfect score. 15 out of 15. He's smart, but some of these questions are pretty tough. Okay, so 10.
I got 10 right. Maybe no, I did not get 10 right. I take that back.
Okay, this is a good one to look at, actually. Okay? Because you'll definitely see this tomorrow. Okay, not necessarily this exact same question, but one like this. Okay, tell us what you do, Jack.
Simply plug in x cubed in for the t, and then you take the derivative of x cubed and multiply it. Ask Daniel, was your question? Yeah, but I want to type.
Okay, so this is fundamental theorem of calculus, which tells us when we take a derivative of an integral, they cancel each other out, more or less, right? But so they're asking us for a derivative of this expression, which is an integral, which is more or less going to cancel out, except this one is going from -1 to x cubed. So you have to do sort of a chain rule here. So you plug in the x cubed for your t, and then you multiply by the derivative of the x cubed, which is 3x squared. So that's going to give you 3x squared times the square root of 2 plus x to the 6, which is...
Did I get that one right?
You really always do it, because if you integrate from, like let's say we're integrating from 3 to x of t squared dt, something like that. And we are taking the derivative of this. So this is a different problem, right? This is not this problem. But when you take the derivative of an integral, what you do is you take this upper limit right here, plug it in for the t, which is going to give you x squared. You multiply it by the derivative of that upper limit, which in this particular case is just 1. So you would get x squared for that derivative. Fundamental theorem of calculus. Yeah, I figured that we had forgotten about that, so I wanted us to go over one of those. Same as always, 3 free response and 18-ish multiple choice.
Oh, I did. Let's go.
Daniel, you did get that one right, though. I know they didn't copy Jack. Daniel was done before everybody else, so. Yeah.
You know why I picked that one?
I guess
Why?
like 4 of them.
Because I knew that if you multiplied things, you would not get x squared.
I did. Mine was
Right, so you eliminate these right here.
Yeah.
Yeah.
That
Okay.
didn't seem too easy.
All right.
Educated guess.
Yeah. All right. Let's see. Please come to school tomorrow.
Grade here than I do, and I'm not requesting this.
Oh, that's very easy. Just look at where it is.
I chose D.
Okay, so this was just understanding what it is. H is the integral. That's the area under the curve from 0 to 6. Then H prime, when we take the derivative of the integral, we would just take the x, we plug it in right here, we get f of x. We get f of x times the derivative of x if you want to do that, which is 1. So h prime of x just equals f of x. So to find h prime of 4, you would just go to 4. Your y coordinate is 5, so 5 would be your answer.
Why is it not undefined?
All right, so if they had asked for f prime of 4, it would be undefined.
All right, let's see. That's what I was expecting.
So, but they asked for h prime. H is the integral of this. So h prime is actually just f.
The derivative of the interval doesn't cancel out, so it's just the thing.
Right. So what we're looking at is h prime. So, so we would just give the value.
Do the y
If they had asked for f double prime or h double prime,
then
it would be undefined.
I understand.
Yeah.
I hope
Okay.
we can have this on the test tomorrow because then I'll get it.
Okay. All right. So,
I'd be closer.
I do want to do one. I fixed a sheet with just a few problems that I thought would be helpful for us to look at. Now I've lost it. Where'd it go? And we're not going to be able to do all of these at all, but I'm going to do the first one.
Whenever they watch this, their basketball season will be over.
The first one multiple choice, or is it?
It might not be everything.
Just know that y'all had a very good season and that y'all beat the boys.
Could they actually beat the boys?
Way to make it the first round. No, they could. I'm convinced they would beat the boys.
You think they would beat the boys?
Yes.
The defending state.
They're playing the defending state champs. Sorry, guys.
They'll beat you.
Hope everything went all right.
You get to go there and
Hope-
cry too much.
Hopefully everybody is still alive. Okay. All right.
There's a fun bus ride, I bet, though.
Probably
no,
so.
No, because Murphy's a.
It's curvy, so I hope nobody threw up. All right. Okay, I want to do this first problem together, and that's probably all we'll have time for. Because there's a problem similar to this, not this exact problem, but similar to this on the test, and everybody always misses it. Okay. Lots of people miss it anyway. And some people that do get it right, their logic is flawed. So, the table below gives selected values of a continuous function, f prime of x. The function is decreasing on the closed interval from 0 to 2. Which of the following could be the exact value of the integral from 0 to 2 of f prime of x dx? So, if we had f of x, it is going to be f of 2 minus f of 0, but do we have f? No. So, this is the area underneath the curve. The only thing you can do here is do an approximation. We know how to do several types of approximations. We can do left Riemann, we could do right Riemann, we could do trapezoidal, we could do midpoint, although midpoint would not be a good idea here. But they told us that f prime is decreasing. So if f prime is decreasing, a left Riemann sum, left is going to be over, and right is under. All right, so if I do the left Riemann sum, I've got 0.5 times, I'm using the left point, so it'd be 10. And all of these have equal subintervals. So, like, from here to here is 0 is 0.5, that's 0.5, that's 0.5, that's 0.5. So I'm just going to put the 0.5 out front. Plus 8, plus 7, plus 5. And whenever you do this, if I did my math right when I was making this problem, you should get 15. So that's the overestimate. It's not A. Then to do your right Riemann sum, you'll do 8 plus 7 plus 5 plus 4. If I did my math right here, you will get 12. It can't be 12. 8's lower than 12. Can't be it. So it's got to be the number in between those. Yeah.
I have a question here in a second.
So, there's one very much like this. Alright, so these problems here on this worksheet, I was hoping that we would have time to go through, but we did not get to them. So I will finish working out the key for this, and I will post it to Canvas. This is not required, but it would be good to look at because I specifically was looking at the test thinking, oh, we might should go back over this. So you want to look at these problems. And the homework for tonight is to do the second progress check. So part B of the progress check. I have a meeting in the morning, so I will not be here in the morning. But I am here during third period, so if you want to come during lunch, that's fine. All right, did you have a question on this one, Thomas?
Why do we use 0.5?
So that is the width of each rectangle, because from 0 to 0.5 is 0.5. And then from 0.5 to 1, that's 0.5. And since they're all the same, I just pulled it out front instead of doing 0.5 times 10 plus 0.5 times 8 plus 0.5 times 7 times 0.5 times 5. But you could do it that way also. We didn't use 10. Or we used 10 on this first one because this was our left Riemann sum. On the second one, it was right. So we didn't use 10, but we did use 4. Yeah.